So for learning target 710, we need to match the correct equation here to the correct graph, and then some very important points, one point on each graph, we need to find the ordered pair of. As I glance through these, I notice that three of these four graphs open up and one of the parabolas opens down. I know enough about equations to know that if it opens down, the coefficient of x squared is negative. So I look, and the only one of these equations where the coefficient of x squared would end up being negative is a. So I know that 4 matches equation A. So 4 matches equation A, and the reason I knew that, because it opens down and the coefficient of x squared is negative. I can leave it at that without any more explanation because it's the only one that opens down and the only one where the coefficient of x squared is negative. If I had 2 that opened down and 2 that opened up, I'd need to have more explanation for that. Now, a point of interest. This is an intercept form, and a point of interest is one of the x-intercepts. Well, the point on the x-axis, y is 0. I'm looking for the negative x-intercept, so the equation, if y is 0, that I would be solving is x plus 2 equals 0. Then when I subtract 2 from both sides, my x here is at negative 2. So this is the point negative 2, 0. While it is true that x minus 6 would also equal 0, if I solve that, that would give me an x value of positive 6. So that's this x-intercept over here, not the one that they're wanting. So that's narrowed it down to 3. Another thing that I notice is that in all of the rest of these, the vertex has shifted from the origin. Actually, in all of them they have. A good clue as to which one they're looking for. They're asking me for another intercept here for problem 2. So that intercept is going to be found from intercept form, which means D has to match up to 2. The reason I know that is if I solve for D and I find the two x-intercepts, I would have x minus 3 equals 0. Add 3 to both sides to get x equals positive 3. Over here, x plus 5 equals 0. Subtract 5 from both sides to get x equals negative 5. It seems reasonable that this one crosses the x-axis at negative 5 and at positive 3. Neither one of these other two even cross the x-axis. If they don't cross the x-axis, there are no x-intercepts, and I would not be able to write it in intercept form. So this is the only one left in intercept form. It's the only one that crosses the x-axis. It's got to be the one that works. So 2 has to match up to equation D, and the reason that I know that 2 matches up to D, it opens up and the x-intercepts are at negative 5 and 3. And I just showed the work for Q to find that that is the point where x is 3 and y was 0. The other ones are a little bit harder to distinguish. I know that this one is in vertex form, and I know because it's in vertex form for C that the vertex is at the point positive 4, positive 3. That could be either one of these, though. This could be the point 4, 3, this vertex, or this could be the point 4, 3, this vertex. The other thing I know, though, is if they give it to me in vertex form, frankly, I got to tell you, they're going to be asking for the vertex. So C goes to 3, and R is the point 4, 3. So why do I know that C matches graph 3? Well, the reason that I know that graph 3 matches equation C because it opens up and the vertex is at 4, 3. That leaves this. It's the one that it's not in intercept form. They're not asking me for an x-intercept. It's not in vertex form. They're not asking me for the vertex. They're asking me for the y-intercept. So the last one is B. The y-intercept is when x is 0. So this becomes y equals 0 squared minus 2 times 0 plus 5. So the y-intercept is at positive 5. And this thing does not cross the x-axis. So y-intercept at positive 5, so the point 0, 5. Why do I know that this is the graph? I know that it's the graph because it opens up and the y-intercept is at y equals 5. It's possible that graph 1 and graph 3 could be a little bit confused. You shouldn't find on your test that there are two that you might think are the same point. But I do know that if the vertex is at positive 5 here, it's not probably very reasonable to think that this is the point 4, 3.